So Illumina is the leading producer of tools and equipment for DNA sequencing. We're a company of about 7,000 employees. Our headquarters is based in San Diego, California. We also have a brand new large campus in Foster City. Foster City, for those of you who don't know, is just a little bit south of San Francisco. So we have several well-known companies that are our customers, companies like 23andMe and Ancestry.com. Now those companies are well-known because they market to customers, but an interesting fact is that 90% of all gene sequencing is done on Illumina equipment. So our equipment is used for more than just sequencing human DNA. It's also used for crops and livestock. And interestingly, Illumina is frequently rated by MIT as among the 50 smartest companies. But a keen observer will note that their rankings have declined since they hired me. So Illumina is best known for our sequencing equipment. We have $20,000 sequencers that sit on your desktop for like small clinics and so forth. But we also have multi-million-dollar machines that can sequence large populations of genetic material. So these sequencing equipment, they can stream their data to our cloud. We call it BaseSpace. BaseSpace is built on AWS. Now, a customer can choose to send two different types of data up to the cloud. It can be simply machine telemetry data that lets us understand how the sequencers are performing, and they can also upload the sequencing results themselves. So then within BaseSpace, they have control over who can see their data. We have granular access controls for HIPAA compliance, but if it's a simple research project, perhaps they want to collaborate with other researchers. But again, the customer is in control. We also have over 80 apps that run in our platform. So Illumina is not only a software as a service provider, but we're a platform as a service provider as well. So we have to remind customers that there's some shared security responsibilities. These apps are essentially containers, so we have an onboarding process for the applications to make sure that, of course, they're at least meet a certain level of trustworthiness. We also have over 27 petabytes of data in Amazon S3. Now, if you're like me, you may not be able to wrap your head around exactly how big a petabyte of data is. But I found a Gizmodo post that said 1 petabyte of data is worth 13.3 years of high-definition video. So what that means, if you were actually going to watch 13.3 years of high-definition video, that would be over 58,000, say, Netflix videos. So in addition to Sequence Hub, we also have 4 other informatics products, one of which is Clarity LIMS. And Clarity LIMS is a laboratory information system. It can be installed either on a customer's network, on their hardware, or it can be offered in the cloud on a single tenant EC2 instance in a its own security group and also in a dedicated AWS account. So this is not really full DevOps yet. We also have 2 other products, BaseSpace Cohort Analyzer and Correlation Engine. These were acquired as part of another acquisition, and they're currently being served out of a data center, a colo service, but we're in the process of migrating these to AWS as well. We like AWS because then we can take advantage of a lot of their security features that we've optimized our security around. And then we built Variant Interpreter from the ground up for working in the cloud and analyzing the data. So that was a brief introduction to Illumina. Now I wanted to spend a little bit of time talking about some of our DevOps philosophies, and then after that, we'll get into the detail of how Illumina implements some of this. So I know that we've been talking about DevOps for almost 2 full days now, but I wanted to show this slide that we use internally to talk about DevOps. And I stole this from Dave Shackelford. Now, Dave Shackelford is the course author for the Security 545 class that I'll be teaching later this week. And he also has a white paper in the reading room if you wanted to check it out. But the big takeaway from this paper is that security teams need to use the same types of automation that operations and development are using as part of their workflows. So 80% of what you do, you'll do over and over again. So from a security perspective, it just makes sense to automate that. And as you can see, and we've been talking about this course for the last couple of days, is that there's appropriate places to plug in your security. And I particularly liked what Frank showed during his talk. We also are heavily influenced by Google. It's kind of funny because if we say, well, Google does it this way, then they're like, oh, okay, their ears perk up. So I've used this slide to talk about, well, DevOps principles, and then also what we can do kind of in alignment with these. So the DevOps, so there's a kind of a cool YouTube video, if you check it out. It's just called DevOps versus SRE. And it's about a 5-minute video. So the first couple minutes, they talk about the DevOps principles that are indicated with the green check marks. And then they talk about how their SREs implement this. And I'm particularly enamored with the idea of measuring toil with the goal of automating this year's job away. So within Illumina, we're trying to take a baby step in this direction by just simply measuring reactive work versus planned work. I like to use the metaphor of alligator fighting versus swamp draining. And this came from a silly sign I saw in a bar in Texas. It said, when you're so busy fighting alligators, how can you possibly drain the swamp? And then from a compliance purpose, we know that it's critical to rotate your credentials, right? So we were spending an inordinate amount of time nagging people to rotate their keys, rotate their credentials. This is in AWS, right? So like Active Directory will send the notices through Exchange to you, but we didn't have that automation in place, and that was making us the bad guys. So now we implemented some automation that says, hey, your credentials are going to expire in 10 days, and then 5 days, and then 1 day, and then we disable the account. So now we can say, hey, this isn't us being the bad guys. It's the automation that you're ignoring. We're also working on getting those credentials completely out of AWS by using a single sign-on. And I'll talk about what we're doing there. We're also huge fans of the Center for Internet Security. So we're working hard on implementing their hardening benchmarks. But we also are fans of the critical controls. So this is the latest critical controls poster. And as you can see, the controls are broken into 3 groups: basic, foundational, and organizational. And some of these controls we can inherit. For example, the wireless access control or web and email protections. We inherit these from our corporate security team. But then there's other controls that our team needs to implement for our particular environment. And I can say that with a level of assurity that we're taking care of all 20 of these critical controls to a certain level of depth. But even though we're being recorded and legal had to review my PowerPoints, I wanted to kind of shift gears and get a little bit real. So the basic controls, you just gotta nail as a cloud security team. So this is just the basic blocking and tackling. So critical control number 1 is have an inventory of all of your hardware assets. Okay, in the cloud, who has access to the hardware assets? Well, that's the cloud service provider. But we as tenants of the cloud have access to the virtualized assets. So this could be EC2 instances, it could be load balancers, or it could be software-defined networking or whatever, right? And then have an inventory of all of the software in your environment. So this could be what software is running on each and every EC2 instance, as well as the libraries and the dependencies that you use for the custom code that you're writing. So what I like to do is just lump them all together and call it, well, inventory all the things. So the other critical controls, continuous vulnerability management, controlled use of admin privileges, secure configurations, log monitoring, are also very critical. So the way that I like to summarize this is you must know what you have, configure it securely, and keep it that way, control who is accessing it, and then know when they do. Again, 80% of what you do, you're going to do over and over again. So get good at it, automate it, script it, and improve those scripts with iterations. So back in the early 90s, the Software Engineering Institute was really promoting their capability maturity model. And if you ever looked at this, it was quite rigorous, but the overarching concept was quite brilliant. The idea was that you could characterize the different phases that a software development process would go through. At the initial phase, there's typically a lot of heroics and all these ad hoc processes. And then as you get to level 2, you get some repeatability, but it's often only at the team level. I don't know if you've ever had to document an SDLC for an organization with an immature software process. I had to earlier in my career with a particular startup, and it gave me a great appreciation for the tongue-in-cheek quote that says, leadership is figuring out where your people are going and then running to get out ahead. So that's what I felt like when I was trying to document an immature SDLC. So then a question is, does automation help an organization mature, or is it mature because it has automation? So the one thing that I know is that scripting a process, scripting your controls, gives you that ability to have it peer reviewed, to have the version control so you know when changes were made. So I'm a big fan of scripting your security capabilities. I also view security capabilities as an organizational asset. Just like a machine. The idea of an organizational asset is that it can appreciate in value if you invest more in it. Similarly, it can atrophy if you don't care and feed that particular capability. So think of like a hostage rescue team, if you will. So their capabilities are a result of experience and planning and drilling to maintain that peak performance. I believe the same is with security incident response as well. But also in some of the more simple things such as security code reviews. So now that I've talked about my security philosophy, let's talk about how we implement some of this at Illumina. I started my electrical engineering career in 1990. Back then, the total quality movement was in full swing and everybody was writing mission statements. But one of the things that was really beat into my head was that which is not measured is not controlled. Later, I had the opportunity to work for an Amazon subsidiary, a company called shopbop.com, and learned that Amazon measured everything and that they were very proud of their data-driven decision-making. And as I've moved from position to position, I've tried to take that mentality with me. As I was especially creating metrics with initiatives that I was trying to drive or when I was trying to influence various organizations. I've also seen teams make the mistake of spending more time keeping score than playing the game. So as a result, I've come to believe strongly that your metrics should be derived as part of your natural work processes and should be most preferably automated. I got a couple examples for you. So we've standardized on Veracode as our static analysis tool. So in the beginning, we had a simple metric. What % of our application code base was receiving a static scan? And then as we achieved a very high rate of adoption, we changed the metric to what % of our code base is getting a passing scan. And then last, we changed it to, well, how much of our applications are getting scanned because it's integrated with the tool chain. Another example is vulnerability management. Does anybody really enjoy vulnerability management? Right. Well, and we were doing it the old-fashioned way, the way that we had done it on premise. We were using a network scanner, right? So, and we were as we started looking into it, we were finding that we had issues. We weren't scanning everything we assumed we were scanning. We also realized that we weren't getting authenticated scans everywhere. And if you don't get authenticated scans, you're missing out on a lot of great data. And in many of our environments, we are really struggling to patch within our service level objective. So I'll talk about what we did with this data in a few slides, but I just kind of wanted to point that out as an example. And then we've also have a major initiative with changing how we access our environment, right? So we have heard that it's a AWS best practice to assume a role in the environment, preferably through something like a single sign-on provider, rather than to have IAM users configured in your accounts. And what we found, well, so we set a goal for ourselves. We said we want 80% of all access, whether it's from automation, like an EC2 instance or a Lambda function, or a human, 80% to be done via assuming a role. We also set a goal for ourselves that we wanted 100% of that to be done with multi-factor authentication, with the exception of when it was automation assuming a role. Now, the interesting thing is when you require MFA for IAM user accounts, you see that it forces some stuff out of the woodwork. So when we were having like EC2 instances with credentials, the IAM user credentials that were right on the EC2 instance, it would break the automation if all of a sudden a human had to go in and enter an MFA token for that automation to work. So it kind of surfaced a bunch of issues, and we're like, well, then let's get it assuming a role, right? But the cool thing about this is all that data is in CloudTrail. You just look at one of the particular fields in the JSON data structure. So a few slides back, I was talking about inventory all the things. So here's an example of some of the things that we felt we needed to inventory. And I often will invoke the Socrates axiom, which is know thyself. Because after all, how can you secure what you don't know? When I first took the job, I wasn't really sure of even the size of our EC2 fleet or how much of that fleet was running Windows, Amazon Linux, CentOS, and so forth. So one of the first things that I did was I created a script that would give me an up-to-the-minute inventory of what we had across all of our different accounts. And then also, as I mentioned, because we have 27 petabytes of data in S3, having an inventory of the S3 buckets was also an important priority for us, as well as knowing what types of data would be in each of those buckets. Because, of course, we also had things like CloudTrail and load balancer logs that were going into S3, so we needed to know where all those logs are. Now, we do use one central account for all of our security logs, so that certainly helped. So besides the EC2 instances that are running in our production environments and our dev environments, we also have some systems like Bastion hosts or Jenkins servers that we need to ensure are properly secured. And any developer can spin up a Jenkins host in a dev environment. And that can be scary if there's not proper security guardrails around that, because can you imagine how much fun an attacker would have if they got access to your Jenkins server? Just a couple of weeks ago, a pen tester tweeted a single line of Python code that would dump all the credentials configured in a Jenkins server if they had access to that box. I find all that very fascinating. So tightly coupled with the notion of generating inventories is knowing how all of those assets are configured. So configuration management is pretty simple, right? It's about knowing what your desired security configuration is for a particular class of assets, and then also knowing what its current state is, right? So then it's about managing the deltas. But what I like about working in the cloud as opposed to working in the on-prem environment is you can query the infrastructure. You can get this information via the command line or via your scripts, and you can get better at it by iteratively improving those scripts. So I would even go as far as to say that if you don't have a good grip on your change control, then you're going to be in this mode of constantly fighting alligators, right? So I even go as far as to say that we define a security incident as any change that bypasses our change control process, regardless of whether there's malicious intent or not. Illumina has about probably about a couple hundred AWS accounts, but roughly 70 of them are in our security domain. So what we do is we have a CSV file that lists all of the AWS accounts, and then this isn't rocket science, but it works for us. We just iterate through each account, and then we iterate through each region. And then we call the particular API call to give us the data on that particular type of asset. And when we first ran this, we found some surprises. We found we had virtual machines running in assets or in regions we didn't expect. So that was pretty interesting. Then, so now we're doing this on a daily basis. We dump it to an S3 bucket, and again, there's fancier systems out there like Redlock, Evident.io, and we even saw some being exampled today on slides that were open source. But this is our security capability, right? And it's appropriate for our level of maturity. What we like about it, though, is we can do diffs from day to day to see how things have changed. We can also run it on demand, of course, if we're in the middle of, say, a security incident or whatever. We can grep it, and other automation can consume it. So this is oversimplified pseudocode. In reality, what we're doing is we're running a Python script using the Bodo 3 library, which is the SDK for AWS. So I have a short link on the slide if you wanted to check it out. Again, it's not anything amazing, but it works for us, and we do this for a bunch of different types of assets. We also use a tool called Prowler. So Prowler was created by a guy named Tony De La Fuente, and it also, we have it running daily and dumping its output to a bucket. And the idea behind Prowler is that it will score your AWS configuration according to the CIS benchmarks for AWS. We also talked about critical control number 5, right? Secure configurations. So we wanted to focus on hardening. So Amazon makes it very easy for you to launch a virtual machine. You just go to the marketplace and you click launch and you have a virtual machine running. However, these images that you launch the machine from in the marketplace are often from an unknown provenance and are rarely hardened. So what we do is we take the most recent Amazon Linux image that's available. In AWS, they call them AMIs, Amazon Machine Image. We take the most recent one, and then we apply our hardening to it. The first thing we do is we apply all the updates and make sure that it's fully patched. Then we'll load our security agents onto it. And then thirdly, we apply our specific configurations that are appropriate to our environment. We bake this twice a week, and then and we do this in a dedicated account called Build Factory. The idea behind Build Factory is it's restricted to a team that is focused on creating the AMIs. Then what we do is we share the AMIs to all of the other AWS accounts that are in scope. We also figured out very quickly that we had to use an IAM policy that would prevent somebody from being able to launch an instance that wasn't one of our quote-unquote blessed ones. We've ran into some interesting stuff where folks will make derivatives of our blessed images. So then we had, a provenance issue, but we've worked through that with applying mandatory tags and that type of thing. We also had to unshare the old images because it may no longer be in a fully patched state as new security vulnerabilities are discovered. And then lastly, we're currently in the process of terminating EC2 instances that are older than our patching SLO. So this is our solution toward trying to patch in place. Instead, what we're doing is we're patching the image. So we're patching way upstream in the build phase rather than when we're trying to operate it. And this was actually quite exciting for me because I had been preaching this for over a year and finally got the organization to make a department level KPI. And then it was exciting for me to see the developers really wrap their minds around this and figure out how they could do this in the different environments without causing too much of a disruption. So in some of these environments, we'll do this in a crawl, walk, run fashion, where we'll start with just turning it off and see what happens. Because we know we've got some technical debt issues to address, things like making sure that it's properly auto-scaling and load balancing properly. Because our goal is to limit the impact of any types of disruptive changes, but then eventually it will become an automated script that will run across all of our environments looking for these instances that are older than our patching SLO. We also spend a lot of time working with our developers, making sure that they have their loosely coupled microservices and that they're fully patched and hardened and no known flaws, that they're sanitizing their inputs and their outputs, and also making sure that they have a clearly defined trust boundary, whether it be a VPC or a dedicated AWS account or whatever, but we want to know what that trust boundary is so that we can properly defend it. I talked about what we're doing with the AWS credentials by requiring the MFA, and it forces the user accounts out of the woodwork. But there is certain things like Tenable IO, interestingly enough, which requires you to have an AWS access key in its cloud to be configured in its cloud connector. So in that case, what we're doing is we're using the IP address whitelisting capability of IAM policies to restrict it to just the IP addresses of that automation. And to do this, you may need to use an elastic IP address so that as you relaunch that automation, you have a known IP address. But we find that that works for us. We're also going for FedRAMP, and if any of you have had to deal with FedRAMP, FedRAMP has a very long list of controls, right? The special publication 800-53 controls. Some of these control owners will be in parts of the organization that are beyond my security team. For example, our corporate security team is involved with securing the laptops. And then there's a designated individual in HR who is responsible for the background checks. So keeping track of all of these control owners is a lot like herding cats. But what we're doing is we're going to use automation for that, right? Why can't you query LDAP, query LDAP against this specific list of control owners? If their title changes, their manager changes, or the cost center they're associated with, that might indicate that that individual has either left the company or taken a different role in the company. So at that point, we need to make sure that the new control owner knows all of their security responsibilities with respect to maintaining our compliance. So this is an example of where you can use security automation to help you on what conventionally has been thought of as a completely manual process. A politician once said, "Never waste a crisis." So I've absconded that thinking and said, well, let's not ever waste a security incident. Bad things can happen to good companies. And I think the secret to success is not about being afraid to make mistakes, but by making sure that you don't make fatal mistakes and by limiting the blast radius, as we've been talking about for the last couple of days. In security, we often will say, well, let's reduce the risk to an acceptable level. But I truly believe that that thinking should be a core part of our design thinking, how we go about designing these systems. But realistically, security incidents can happen. Hopefully they don't end up on the front page or make it to the executive board level. So there is one security incident I can talk about. We have a developer sandbox. We had a developer who was going through an AWS tutorial, and this person spun up a WordPress and then actually left the company to go back to school. And of course, that WordPress box got popped. And we exercised our forensic incident response capability and analyzed it. We wanted to make sure, of course, there wasn't any company intellectual property on the box or, God forbid, customer data, and we satisfied ourselves that it wasn't. But then we also took a look at what did the attacker do on this system, right? So it was almost like this honeypot after the fact. But one of the things that SANS teaches is the offense informs the defense. And I learned a lot by that. That was my first incident that I had handled within Illumina. I've done a couple others since and ended up writing a gold paper that I'm rather proud of. It's the digital forensic analysis of EC2 instances. So that's available also in the reading room. So yeah, never waste a security incident and use that to drive your security agenda forward, especially when you have that teachable moment. And this also underscores why it's so important to use this security automation to make sure that you don't regress in terms of the security controls that you're putting your faith in, right? So great talk by Aaron about the resilience here, right? So making sure that the controls that we're counting on, that our customers are trusting in, are in place. So in conclusion, I just have a couple thoughts for you. One is leverage security automation to treat your top risks. I personally think it's the only way that we as a security team can scale and rise to the occasion. Also, use metrics to drive your organizational change. Companies want this data to help them make solid decisions. So lead the way with metrics that support your security agenda. And then lastly, we learned that the security team may need new skills. You might need to hire somebody with mad programming skills to help you implement some of the security automation. But you also may need seasoned technical program managers that can help drive the change that addresses the issues that those metrics illuminate. So I wanted to close with this last thought that says, an organization's ability to learn and translate that learning into action rapidly is the ultimate competitive advantage. The more I do this, the more that I'm convinced than ever that our scripted security capabilities can truly be a competitive differentiator. It's about learning fast, often by the mistakes that we make, and then putting in the appropriate safeguards to make sure that we don't make the same mistake in the exact same way.